Lecture 50, Vector Integration. In that lecture, we discuss the basic concept of line integral. So the line integral, the integral which is evaluated along a curve is called line integral. Sometimes we say the path integral, contour integral, and the curve integral. Here the integrand may be the scalar field or the vector field. So suppose we have a simple curve C and the parametric representation of that C be written as x equal to xt, y is equal to yt, and z equal to zt. And the position vector of the path on the curve C can be written by the vector r, which is xt, I, ytj, and ztk. So suppose we have a curve and we have to integrate along this curve. So here the line integration of the vector function f, suppose we have a vector function f over the C, is defined as integration f dot dr vector. So you have to remember that is representing the line integration, the vector function f dot dr. So by the help of that we can evaluate the line integral. Now take an example. Suppose we have a force F, x cube I plus yj plus zk is a force field, and we have to find the work done by the force F along the line which is passing through that point. So first we have to write the equation of the line which is passing through this point. So the equation of line in 3D which is passing through that point. So if you remember, x minus x1, x2 minus x1, y minus y1, y2 minus y1, and z minus z1 upon z2 minus z1. So the equation of line, we get x minus 1, 3 minus 1, y minus 2, 5 minus 2, z minus 3, and 7 minus 3. We just take is equal to small t. So x we get 2t plus 1, and y we get 3t plus 2, and z is equal to 4t plus 3. Now we open the value of x, y, z. So as you know, the position vector is what r, which is xi, yj, and zk. Now we have to find the dr. We take the differentiation, so we write I dx, j vector dy, k dz. Now the value of dx, dy, dz, we can take the derivative of x, y, z. So we get the derivative of x is what? 2t. So we write 2 dt I, and the derivative of y is 3 dt j and 4 dt k. So that is dr. Now we have to also find the limit, means we have to find the value of t at that point, on that point. So at point 1, 2, 3, if we put this point in that equation, so we can say t is 0, and at 3, 5, 7, t become 3 minus 1, we get 1. Now we have evaluated the work done because we have to find the work done. So work done is what? Integration f vector f, that is a force field, dot dr. Now we write integration f is what? That is x cube I, yj, and zk, that's in force field, dot dr 2 dt I 3 dt j and 4 dt k. Here we put the value of xyz in terms of t. So we write 2t plus 1 I 3t plus 2 j and 4t plus 3 k, and the dot product with that is dr 2 dt I plus 3 dt j and plus 4 dt k. Now there is a dot product, so I dot I is 1, so we write integration 2t plus 1 dt and j dot j, that is 3. We have here 2, 3 3t plus 2 dt, and similarly for k we write 4 4t plus 3 dt. Now take the limit of t vary from 0 to 1, so we write 0 to 1 and we just simplify. We get 0 to 1 and on simplify that is 4t 9t and 16t. Sorry, here we have a cube, that's an x cube, so we write 2t plus 1 whole cube, and after simplify, after expanding this, so on simplify we get 16t cube plus 24t square plus 37t plus 20 dt, and on integration and substitute the limit we get 101 by 2. You can easily integrate that term. So in that way we can evaluate the work done by using the line integral. Now next example, we have to evaluate the line integral where f is, we have a vector x square I plus y cube j and the curve is an arc of parabola, that is y equal to x square in xy plane, and we have to evaluate that integral from 0 0 0.00 to 1 1. Means we have to evaluate that integral along that parabola between that point. So here first we write the in x, if we taking the xy plane, here the vector is defined in xy plane. So xy plane, the position vector we write xi yj. So dr is what? dxi plus dyj. Now because we have to evaluate the integral f dot dr, it means f is x square I y cube j dot dxi plus dyj. So take the dot product, means we have to evaluate the integral x square dx I dot I plus j dot j1, so we write y cube dy, means we have to evaluate that integral along the curve. The given curve is what? Y is equal to x square. So here we can say dy is equal to 2x dx if we take the derivative here. Now then if we put in that equation or in that integral, so we write f dot dr, that is c on the place x square dx plus y we write x square whole cube, and the place of dy we write 2x dx. Now, now here you see that the integral f dot dr, that is we write x, this is x square, so we write x square plus, and that's become x raised to power 2, sorry, x raised to power 6 into 2x, that is 2x raised to power 7 dx. Now we put the limit of x, and here on that curve x varies from 0 to 1. So we write the limit is what? 0 to 1. And on integration we get x cubed by 3, 2x raised to power 8 by 8. The limit is 0 to 1. And on substituting the limit we get 7 by 12. So we evaluate in that way we evaluate the line integral along the parabola. Next example, we have to evaluate again the line integral, and here the vector f is given. Along the curve C is a rectangle in xy plane which is bounded by y equal to 0, x equal to a, y equal to b, and x equal to 0. So first we plot that lines on the 2D plane. That is, suppose this is an origin 0 0, and that's an x-axis. So here we have to, the bounded region we have given is y equal to 0, so that is y is equal to 0, and we say that is the line x equal to, suppose this is the point a 0, so that's in line x equal to a, and that line y equal to, we take if this is a point 0 p, so this is a line y equal to p, and the intersecting point, that is we get the point AB, so we name as O, that's capital A, that's we say capital P, and that's we say capital C. Now we have to evaluate the integral, and that's in line x is equal to 0. So the region which is bounded by that line, we have to evaluate that line integral. So we evaluate the line integral along these lines. This one, that is CO, O, A, AB, and we can say BC. So here first we write the, as you know, in two-dimension plane, the position vector r is what? Xi plus yj, that is z is equal to 0. So dr is dxi dyj. Now we write the limit along these lines. So along the line, first we take the line OA. So we can say here on that plane y is equal to 0, so and x varies from 0 to a, and similarly along the line, if we take line AB, here AB, x is equal to a, and we can say here if we take the derivative, so dx is equal to 0, and we can say y varies, here y is varies a to 0 to b, here y is 0 and 0 to b. Similarly for the line, if we take that line, along that line BC, here y is equal to p, and dy is equal to 0, and here x varies from, here x varies from a to 0, and that point a and that point 0. So you have to remember the direction, x varies from 0 to a. And similarly along the line CO, if we take that CO, so here x is equal to 0, dx is equal to 0, and y varies, here y varies b to 0. Here first I write the integral, that is integration f dot dr. So that vector dot product with dr, so we write that is x square plus y square dx plus sorry, we get minus here, minus 2xy dy. So we have to evaluate that integral along this line. Now, after writing the limits, you have to remember in which direction you are doing the integration. So the integral f dot dr, that is the c is a curve, or we can say the line. So we first break that integral along OA, f dot dr, integral along AB, f dot dr, that is an f is vector, and along BC, f dot dr, and along CO, f dot dr. Now when we take OA along O line OA, that is y is equal to 0, so we put in that integral y equal to 0 and dy is equal to 0. So that integral become x square dx, and the limit of x from OA is vary 0 to a. Similarly, when we take the integration along the line AB, so when we take the integration along AB, so x is equal to, we put a in that equation, and dx is equal to 0, and y varies 0 to b. So we get that part is 0, so we get minus 2ay dy, and y varies 0 to b. Similarly, we take the integration along the line BC, that line. So here y is equal to b and dy is 0, and x varies from a to 0. So here we put in that, we say the input put y equal to b. So the integration is, we get x square plus b square, and dy is 0. The limit varies the limit of x varies from a to 0, and similarly for the line CO, that is x is 0 here, dx is 0, and y varies b to 0. So here we put x equal to 0, dx is 0, so we write minus 2, that integral becomes 0 because we write on the place of x we put 0. So 0, 0 to b to 0. Now on taking the integration, we get the value 2ab. I'm writing directly the result, which is minus 2ab square. You can easily integrate the term. So in that way we can evaluate the line integral. Only you have to remember, when you integrate along the line, you have to remember the direction, because in that case if you take the integration a to O, and on the place of AB you write B to A, you also take the direction clockwise or anti-clockwise. Next example, if suppose we have a vector f y I x j, and we have to evaluate the line integral from 0 0 to 1 1 along the following path. We have two paths, and the first one is parabola y equal to x square, that's a green line, and the straight line 0 0 1 0 and 1 1, the point 0 0 1 0 and 1 1. So we have to evaluate the line integral along this, the first one along that parabola and along these lines. Now first we write the f dot dr, as you remember, yi xj dxi dyj. So we get y dx x dy. Here the f is, the vector f is yi xj. Now the first part, here the c is what, is an arc y equal to x square, and it vary from 0 0 to 1 1, that's in point 0 0 and to 1 1. So the dy is what, dy is 2x dx, and here the x varies from 0 to 1. So the integration from that, we can say this is the equation number 1. So we substitute here, dy is equal to 2x dy, and we get x squared dx, x 2x dy, and on taking the integration and apply the limit, we get minus 1 by 3. And similarly for the second part, here the c consists of a straight line, that's an OB, that line, and BA. So when we take the along the integration OB, so here what, y is equal to 0, so dy is equal to 0, and here x varies 0 to 1. And when we take the integral along that line, so here we can say x is equal to, the equation of that line is x equal to 1, dx equal to 0, and y varies 0 to 1. Now put in the integration, so we get 0 to 1, and because we are taking that integral along OB, and this is the integration along BA, so in that case it varies from 0 to 1 and y is 0. So from for equation 1, y is 0, so we get 0, and dy is 0, so the whole equation become 0. And when we take the integration along BA, so here we put x equal to 1, so x equal to 1, and dx is 0, so we get minus 1 dy, and on integration we get the integration is minus y, and we put the limit, so we get minus 1. So in that way we can evaluate the line integral along the lines, or we can say along the curve.